this repeats. Okay, so let's see what the B does to these graphs now. Okay, so let's see what the B does to the graph. Let's go back here. Let's put my A value back to 1. Okay, so let's see what the B. Now remember what the B value is. You look at where the B is in the equation. The B is right here. It's inside the function. It's almost as if you just replace the sign with an F. Just put an F there instead. You just have a function notation. The B would be multiplied with the X. So that's your horizontal stretch factor. Okay, so now you look at the period of this graph before we start. The period is 360. So if I make the B 2, then my reciprocal B is 1 over 2. My stretch factor is going to be a half. So if I make my B 2, I'm just going to type 2 in. It's going to make the green graph is what we're looking at here. The red graph is the original graph. That's 360. Now my new graph, one period is 180. So that's half of 360, which was kind of what we expected. As I increase my B value, my period decreases in size. So like this right here, I can fit, because the B value is 7, what that's saying is that I can fit 7 whole graphs in one full period of 360. So that means the period of one graph, one green graph here, is 1/7 of the original period. So 360 divided by 7, which would be whatever that number is there. We can pick a better number like 6, right? So 360 divided by 6 is 60. So that's one full rotation right there to this point here. And then 120, and 180, 240, 300, then we get back to 360. 150, missed a 150 there. Okay. No, and I didn't miss the 150. It just kind of looked kind of weird because of where the spacing of the dots were. Okay. So it also changes my zeros too. All my zeros have also squished in as well, right? Because the zeros were on the x-axis. I'm stretching about the y-axis, so they are stretched in or squished in as well. Now, if my B value, not 0, let's not do 0. My B value is like half. What's that going to do? Is it what's the reciprocal of a half? What's 1 over a half? Well, it's 2. 2 times 360, 720. So my new period is twice the size it was before. And then you could do negative B values. Negative B values will just reflect the graph. So here's -1. I was going to reflect it this way. That's very similar to reflecting it this way in terms of this graph. So usually our B values are going to be positive numbers, but you could have negative B values. You could, but usually we just leave our B values as positive numbers because you can represent the same way with a negative A value. Okay, so the B value does a vertical or horizontal stretch by a factor of the reciprocal. So let's just look at these graphs here. So here's my regular graph. So I'm going to sketch sine x. Sine x. This is just the regular one. So when I'm at 0, these are all the y values of on my unit circle. So here, my y value is 0, so I start at 0. At 90 degrees, my y value is 1, 0, -1, and I'm back. So I'm going to kind of sketch this out here. So it looks like that. Okay. Now this here, when I put a 3 in it, is going to squish it. It's going to do a horizontal stretch by a factor of 1/3. So everything's going to be squished in by 1/3. So this, because it's about the y-axis, that's going to stay the same. But I'm going to have 90 divided by 3. What's 90 divided by 3? So 30. So that's why these little ticks are here. So this top point here, the maximum point, it's going to be stretched inwards. It's going to be squished inwards by a factor of 1/3. So that's going to start here now. 180, what's 180 divided by 3? So 60. So this point 180 is now going to be 1/3 of what it was before, so it's going to be at 60. Then 270 divided by 3 is 90. So this point over here is going to be stretched in. So my graph is now going to look like this. Okay, so my period of the original graph is 2/3, or sorry, 2 pi, because you could, oh, it's actually not in pi, this is in degrees right now, so let's stick with degrees. 360, my new period is going to be whatever 360 divided by 3 is. So it's going to be 360 divided by 3. So 1/3 of the original, so 120. So that hits about 120 there. And then I can continue these on, right? So my original zeros were 0, 180, and 360. Those are the ones I can see there in the graph. Now my new zeros are going to be 0, what did I say it was before, 60, and 120. So all my zeros are also 1/3 of what they were before, because the stretch factor, I'm just going to put that here, a horizontal stretch factor of 1/3. Now, if I talk about the stretch factors and how these things relate to translations, I probably could, or transformations, I could probably skip a lesson later on and make this a little bit shorter. So here, my b value, if you want to separate these two, you can. My b value is 1/3 x. If it's 1/3, the reciprocal of that is 3. So I'm doing a horizontal stretch by a factor of 3 about the y-axis. I'm just going to ignore that part for now. Okay. So we're going to go to the original graph. I'm going to just multiply all the x values, all the x, yeah, so x values here by 3. So 0 times 3, 90 times 3, 90 times 3, so 270. Where's 270 on this graph here? We go here. Let's go right. What's 180 times 3? So 540, so right about here. Okay, and then what's 270 times 3? So we're just timesing all the x values. So 810, right about here. And then 360 times 3 is 1080. Yeah, 1080. So then your graph looks like this. I stretch out. Now my period then is going to be, it's going to be 360 times 3. Not divide by 3 like this other one, but it's going to be times 3. It's going to be times 1/3, right? They're times the reciprocal of that b value. My zeros are going to be 0, 540. They're going to be 3 times what they were before, because it's affecting the x values here. There you go. Pretty good. This is going to do the same thing, right? In this case, we're doing by 2s rather than by 3s. So if I'm going to graph cos x, I'm just going to start by graphing cos x. Remember, this is graphing the x values on my unit circle. So starting off at the beginning at angle 0, my x value is 0, or 1, sorry. At 90 degrees, my x value is 0. 180, I'm back to -1, and then back here, and then to here. So my graph looks more like that. There you go. So this here does a horizontal. Oh, I'm sorry, my period. My period is 2. Oh, so we're still in degrees. Okay. So 360. My zeros in this case are 90 and 270. The ones that we can see at least. Okay. So this is going to do a horizontal stretch by a factor of 1/2, right? So that means my period should end up being a half of what it was before this if we divide by 2. So that would be 180. And that also means all my zeros should be half of what they were before. So 90 is now 45. 270 is 135, etc. Okay? So I'm going to start off at 1. I'm not going to do a horizontal stretch of a half on that because it's changing my x values. My x value is 0. 0 times a half is a half. Or 0 times, sorry. 0 times a half, yeah, 0, sorry. Okay. And then this point here is now 45. the 180, a half of 180 is 90. So my graph is going to look more like this now. Half the size. If you want to, you can continue on, but you don't have to, but I could do this. Show what the other part of the graph looks like. So I can see 2 full periods in this part. Yeah, so it does match up. 180 is 1 period, crest to crest, and my 0 is 45 and 135. Yeah. Here I'm doing a horizontal stretch by a factor of 1, because this here turns, if you could just want to write that out a little bit differently, this is a half times x. That's the same thing as saying divide by 2. So the reciprocal of a half is 2. So I'm stretching everything by 2. So the original period was 360 times this by 2 over 1, because that's the reciprocal of a half. I get 720. So my new period is going to be 720. So that means it's got to come back to the same spot it was before. And all my zeros are going to be 2 times what they were before. So it was 90. Now it's going to be 180. So I know it's going to have to cross here. And then it was 270 times 2, 540. So it's going to cross here. The graph will look like this, assuming these ticks are 1 here. So 1 full period is 720. So that was right. And this point here. There you go. Looking pretty good. We haven't talked about general terms regarding these, but as you start stretching the graph, you start stretching how far apart each of the zeros are. Like if I do a factor of a half, my zeros are now only 90 apart from each other. So every zero is going to be plus 90. Or if I stretch it by a factor of 2, all my zeros are now going to be 360 apart from each other. So the stretch factor also affects the general term as well. All right, so here's a little shortcut of what we did. All right, we didn't do any of the radian measurements here. So rather than saying 360, I could have said 2 pi for all these graphs. And if I know what the b value is, I take the reciprocal of it and I times it by the original period of the sine or cos graph. We're going to talk about this later on, but tan graphs have a different period. They have a period of a pi, but it has the same kind of logic. If my b value is 2, then be pi over 2, or 180 over 2. Right. Then it also just talks about, it's just a horizontal stretch factor. You could do a reflection as well, but then they do a horizontal stretch factor, 1 over that value. Okay, well, I didn't start my timer, so I don't know how long I've been going at this so far. Probably enough, so I'm just going to stop this video here, give you a little bit of time to work through these next few examples, and then the next part of this, I'll come back and give you the answers. Well, see you in the next video. Bye.